Days ago, Apple sued OpenAI. The lawsuit reads like a spy novel. Stolen trade secrets, poached engineers, confidential hardware. And Apple is right to be scared. But not for the reason in the filing. Apple's real fear isn't that OpenAI copies its hardware. It's that OpenAI is about to make Apple's hardware not matter. And no lawsuit can stop that. The real story hides in a number measured in milliseconds. To see it, watch one AI do the same task two very different ways.
But why would the world's biggest company fear a millisecond? The reason is hidden deep inside how AI agents actually use a computer. So in this video, we're going to open that up. And the best way to start is a simple experiment. We take one AI model, one brain, and give it the same job two ways. Way one, through code. The model makes a handful of function calls. Search flights, San Francisco to New York. Filter for nonstop under $300. Pick the cheapest, book it. 4 steps, each one clean, structured data going straight in and straight back out. Done in milliseconds. This is why AI coding assistants actually work today. Way 2, the same brain has to work the way you do, through the screen. Pointing, clicking, scrolling, typing, and it's still going. Screenshot number 7, step 9. Minutes pass. Half the time, it fails completely. Same intelligence, 100 times slower. The difference is the interface. Those buttons and menus were never the task. They were an adapter built for human hands. And that gap, milliseconds versus minutes, is the crack in Apple's fortress.
So why is the screen so slow for an AI? Because a computer use agent gets exactly what you get. A picture of the screen, a mouse, and a keyboard. No secret backdoor into the app. Watch one single step. Take a screenshot, upload it. The model decodes 2 million pixels, more than 2,500 tokens, just to find one button. It decides exactly one action. Click at position 812, 344. Then it waits for the page to react, spinners, animations, and takes another screenshot to see what happened. That is one step. A real task takes 30. In one study, formatting 2 paragraphs in a document, 30 seconds for a human, took a state-of-the-art agent 12 minutes. And here's the twist. Most of that time, the AI isn't thinking. It's waiting to see.
Living like this is like doing your whole job through a Polaroid camera. Snap, wait for the photo to develop, study it, move your hand 1 inch. Snap again. And the photos pile up. The agent's memory fills with old screenshots, so every step gets slower than the last. Worse, the screen is a moving target. Animations, loading spinners, a cookie pop-up that appeared out of nowhere. The photo you took 3 seconds ago is already a lie. You run this loop effortlessly, for free, all day long. A machine pays full price for every single frame.
And there's an even deeper problem than speed. The reason AI improved so fast in recent years is reinforcement learning. Let the model try a task 1,000,000 times and reward every success. But that only works if a computer can check success automatically. Code is checkable. Do the tests pass? Green check, red cross, a perfect instant referee millions of times a day. Now try to referee a visual task. The agent edits a photo. Is the brightness correct? Is that text sitting on top of other text? Did the crop just cut off someone's head? You see these mistakes instantly, but there is no pass-fail test you can run 1,000,000 times. The reward is fuzzy, and when the reward is fuzzy, the engine behind AI's biggest leaps gets no traction. So pixels are slow to read and nearly impossible to grade. The fix was never a smarter model. The fix is getting rid of the pixels, and one company is betting everything on exactly that.
So what does a computer without pixels look like? Apps stop being pictures and start being tools. Order, pay, search, book. There's already a standard for this. It's called MCP. Think USB-C for AI. One connector, any app. Plug in,
Call the tool milliseconds. But retrofitting 40 years of software, app by app, is painfully slow. And the operating system underneath still assumes a human at the wheel. Sam Altman said it himself. Current computers were designed for a world without AI. So the endgame is an operating system built for agents from scratch. Apps become bundles of tools. The screen becomes an optional window for humans to watch. And latency collapses from seconds per click to milliseconds per call. And now everything clicks. OpenAI paid $6.5 billion for I.O., the hardware company of Jony Ive, the man who designed the iPhone. Together, they're building a device where the agent is the interface. So Apple went to court. But read that lawsuit again. Trade secrets, poached engineers, hardware tricks. Apple is fighting to stop OpenAI from copying its hardware. That was never the real threat. The real threat is that the agent makes Apple's empire, 2 million apps built for fingers, simply unnecessary. Buttons, menus, touchscreens, the exact things that make agents slow. The moat became the trap. And Apple has no frontier model to fight back with. Siri delayed again and again. $1 billion a year to rent a brain from Google. Top AI researchers walking out the door. This is what an agentic operating system actually threatens. Not a feature, not a phone. 20 years of iOS dominance. You can sue an engineer for stealing files. You cannot sue a platform shift. That's the fear. Not a stolen design, a better computer.
But there's a deeper reason this race matters, and it goes way beyond phones. The computer is the perfect training gym for AI. Think about what an agent gets here for free. It trains in the exact same world where it will work. Zero gap between practice and reality. It needs no simulator because the world is the software. It gets infinite resets. New virtual machine, clean slate, try again. And every mistake can be undone. No robot anywhere gets a single one of those gifts. So here's the test that actually matters. If we can't make agents reliable here, in the friendliest world an AI will ever see, they are nowhere near ready for bodies. Because a robot runs the exact same loop. See, think, act. And that seeing part, it's still basically taking a screenshot. A camera frame handed to a reasoning model exactly as slow as everything we just showed you. But the physical world grades on a brutally harder curve. Balancing a body takes hundreds of corrections every second. Robot hardware runs at 100 to 1,000 hertz. The big AI brains we rely on for that reasoning are nowhere near that fast. A single response from a large model can take several seconds. And for the largest trillion parameter models, sometimes whole minutes. In the digital world, that gap just means waiting. In the physical world, the coffee cup is already falling. Nothing pauses, nothing buffers. And when the agent gets something wrong, it isn't a wrong click you can undo. It's broken glass, a dented car, a hurt person. There is no Control Z in reality.
So here's the secret behind the AI agent hype. Latency isn't an inconvenience. It's the wall between a demo and a deployment. The company that removes the loop owns the next platform. And remember, OpenAI isn't just chasing a smaller number. It's betting that an agentic operating system built around that shorter loop can disrupt hardware giants like Apple and Google the same way the iPhone once disrupted them. Watch where the loop is getting shorter. That's where AI will actually arrive first. Now that you understand the latency constraints of computer use agents and why visual processing in even a simulated environment is this hard, we're going to go into the details of exactly why robots have it even harder. If this changed how you see AI, hit subscribe so you don't miss it. Thanks for watching, and I'll see you in the next one.